Area is base times height. Otherwise known, and they also sometimes put it as length times width. Same thing. You're just taking the measurements of two sides, multiplying it, boom, there's your area. So I need to know, let's call this, can call this one the height. Just pick 2. Why do I only need 2? Do I need to know the rest of them? No, why not? Right, it's a square. So if you
Because the
got
sides of the squares are all equal.
they're all equal. Okay. Now we think it's a square. We need to be sure. Once we calculate the distances, we'll know for sure. Because if they're equal, then you know you have a square. But if they're different than each other, then it's not a square. So let's go ahead and do the distance of ML.
Okay.
This is 4, 1 and -1, -2. Distance formula. Should be memorized by now. What is it? Distance formula, the square root of what?
Oh.
No, I can't hear you, Janelle's. No, I can't hear you. I don't know if your mic is not working or something.
Hello, hello. Oh,
Now,
there.
now I can hear you.
Okay, I was gonna say it's the square root of x2 minus x1 to the power of 2 plus y2 minus y1.
Good. Okay. Now I can plug everything in. Here we go. X2 minus x1, that's going to be 4 minus -1 squared. Y2 minus y1, that's going to be 1 minus -2 squared. Questions on that? Good. Okay, here we go. Just get those numbers on the inside of the parentheses. What's 4 minus -1? Good, that's 5 squared. And then 1 minus -2, 3 squared. So this is the square root of 25 plus 9. 25 plus 9 is 34, like Perla said. So that's 34. Okay, I'm going to leave it under the radical because once we put it into our area formula, it might make the radical go away. We'll see what happens. ML, or sorry, KL. K is -3, comma 3. No, -4, comma 3. Okay, go ahead and do KL on your own. Same answer. Good, Janelle's. Yeah, you end up with 5 minus -1, or -4 minus -1 is -3 squared. And then here you get 5 squared. So we again end up with the square root of 34. Questions on the distance formula and how to plug those numbers in to get your answers. This is the time to ask questions is now. Do not leave today's class if you don't know how to do the distance formula. Okay. Now that I have my two distances, base times height, well, this is going to be the square root of 34 times the square root of 34. What is it when you multiply the two same numbers, or something by itself? What is that called? Like if I do 4 times 4 or 6 times 6, what am I doing? Careful, square root is the radical. But when you multiply something by itself, you're going to the second power. Okay, good. So would you guys agree that, I know that's what you meant, but just make sure we're using the correct vocabulary. So would you guys agree that if I'm doing the square root of 34 times the square root of 34, that's just the square root of 34 squared? Would you agree? We agree? Okay. Well, what happens when you have, what happens here? Does anything cancel out? Yeah, because remember, the square root is the opposite of the power of 2, of what the exponent of 2. So if I take the square root of 34 and then I bring it to the second power, this is inverse operations. That cancels out, and I'm left with just 34 as my final answer. Which you can also try this on your calculator. If you actually do 34, squared, what's 34 to the power of 2? Put it into your calculator. 34 times 34, what's that? 1156. What's the square root of 1156? Flip it around, take the square root. You get 34. Leads you to the same answer. And that's because the square root is the opposite of going to the second power. All right, questions on this problem? All right, let's do another. I'm going to skip this one because you do not need to know how to do the area of a parallelogram. That is not required. Let me find one that I like. Yeah, we'll do this one. Okay. So first thing, let me make a disclaimer. Composite figures, which we're about to do, they are not on the topic test, but they are, let me write this somewhere else, but they are on the EOC. So you don't necessarily have to memorize them or practice them for the next test, which is coming up, but they are on the EOC, so you will have to know them later on. So we're going to do them now, and then study it later when it's a little bit closer to the test. Thank you, guys. All right. What is a composite figure? Can I have a volunteer to read? Okay, guys, just somebody read, please. We always waste so much time with this.
Yeah, this class is, wait, Yeah, my microphone works. Okay, this class is too quiet, and I'm gonna try to read through my lagging computer that keeps lagging and moving. So
I'll go ahead,
Uh,
Alejandro.
it come. My God, it's freaking lagging. You know, I can't read. It's moving. The screen is moving everywhere.
Uh-oh. Okay. Someone else. Tyrone, go ahead.
A composite figure is made of simple shapes such as triangles, rectangles, and parallelograms. Is that it?
You can keep reading.
To find the area of a composite figure, find the areas of the simple shapes and then use the area addition postulate. You can use the area addition postulate to find the area of a composite figure.
Good. And the area addition postulate just basically says that the area of a whole region is the sum of all of the mini areas you find inside of it. Now, I know that seems like a lot. We're going to do an example. It's actually not that hard. All right. Take another 30 seconds to write down just the part that I highlighted. Ooh, I am sneezy today.
Bless you.
Thank you. All right. So let's look at our first composite figure. I have a pentagon. Okay, got 5 sides, 5 corners. And if you look, they kind of do this for you, but you can basically break down this pentagon into some different parts. So what do you guys know? What different types of shapes do you guys see within the pentagon? Triangles and a rectangle. Good. So I have this triangle over here. Now the FB, BF, what is that of this triangle? Good, Jalen. That's my height. And then, okay, so that's one triangle. There's also this one over here. And where's the height of that one? Yeah, it's 2. Where did you look, Perla? From where to where? Good, GC. So that's the height. And then you can say that this is the base. And then we've got the rectangle, which is just this big guy right here. So what we need to do is we need to find the area of each of these smaller shapes, and then we can basically add them all up. Okay, Janelle's is asking, why is that the height? Well, that's because think of this triangle like it's kind of tipped over. If I drew it this way, so this is C, this is G, and this is D. Think of it like tipping it over, okay? Here's my right angle. There's my right angle. This is the height, which is 2, because we counted. And then the other one's the base. All right. So what I want us to do first is go look at every shape and figure out which of those can you actually, do we need the distance formula for any of them? Look through it. Is there anywhere where we actually would need the distance formula, or can you pretty much count everything? Okay, Tyrone, where am I going to need the distance formula? The sides. Which sides? Be more specific. Yeah, you can pretty much count everything. We don't need the distance formula for this example. So go ahead and tell me if you can just pick one distance to count, and count it, and tell me what you get. Okay, so let's see. AE is 4. Good. BF, where is that? Is 2. Good. ED is 6. Nice job. FC is 3. Okay, yes, FC is 3, Janelle's, you're right, but the base is AC. So we need that whole long, for the green triangle, from A all the way to C. And then I also needed the base of the purple triangle. There we go, AC is 8. Okay, just missing the base of the purple triangle, which is 4. All right, cool. So now I can find the areas that I need. So the area of triangle ABC, we need 1/2 times base times height. So this is going to be 1/2 times 8 times 2. What do I get? Yeah, we got 8. Good. Let's do the purple triangle. Area of triangle CDF. 1/2 base times height. That's going to be 1/2 times 4 times 2. What do I get? Good, 4. And finally, for my rectangle, what is the formula for rectangle? Base times height, as Jalen said. So that's just going to be 6 times 4, which is 24. So my whole figure, the area of A, B, C, D, E, we're going to just add everything up. What do you got? $36. That's it. So composite figures, they're not always going to give you, you know how on this example they kind of showed you what it breaks down into? They're not always going to do that. So you might get a shape and then you kind of have to break it down yourself. Notice in this case, we did not need the distance formula. Why did we not need the distance formula? We were able to count the units because all of those lines that we counted, they were either vertical or horizontal. So you always want to try to break it down using vertical or horizontal lines so that you can avoid using the distance formula. They were completely vertical and horizontal. Now, Perla, be careful with the word straight, because you can have a straight line that is diagonal, right? So the key words are horizontal and vertical. That's okay. Now you know. So here's an example where they don't break it down for you. But we're going to try to break it down. Again, trying to use as many vertical lines and horizontal lines as possible, and trying to make, we need triangles and we need rectangles if possible. So what is one suggestion of 2 lines that I can connect, or 2 dots that I can connect? Q and R, they're already connected. Remember, I need to break this down even further. Q and T, but is QT going to be a vertical or horizontal line? No, right? So it's not wrong, like you can do that, Tyrone, but then we're gonna have to use the distance formula, which I kind of want to avoid. RT, there's a good one, TR. See, that one's good because that is a horizontal line. Perla, you put -3, 4, -3, 4, and T. So that's not -3, 4. That's a little bit under -3, 4. So that's not really going to work either. Is there anything that we can do to make that connects 2 more dots that can make a easy to work with figure? There might not be anything else you can do at this time, which is okay. We can figure something else out. But I just want to see if anyone notices at least one more. So only triangles. Basically, yeah, no matter what you try, it looks like we don't really get anywhere that's helpful, right? Because let's say I want to do, I don't know, T to Q. What does that give me? That might be a little helpful at least. Yeah, now I have 3 triangles. I can try to work with that. Let's at least get started with these and then see if there's something else we can do for the rest of it. So far I have these 2 right triangles. Right triangles are really useful because right triangles, you can, the hypotenuse, don't count it. The 2 legs can be your base and your height. So which one of these 2 can be my base and which one can be my height? Look at just the legs, don't look at the hypotenuse. So TR can be the base, good. And then what would be the height? If that's the base, good, TS would be the height. So there's an easy one. And then we have this triangle, which is also a right triangle. So we can do the same thing. What would be my base? What would be my height? TR would be the base, so that's also the base here. And then QR would be the height. Good. So let's start with these because they're easier. And then we'll see what to do about that last triangle. So TSR. What's my formula again? It's a triangle, so be careful. Okay, good. Divided by 2. So 1/2, yeah. 1/2 base times height. So this is 1/2. What's my base? Count it. That's the height, Janelle's. What's the base? 6, good. So 6 times 2. And then times 1/2, what do we get? Good, we get 6. Okay, what about my green triangle? Triangle QTR. Yeah, it's the same. 1/2 times base, which is 6, times the height, which is 2. We also get 6. Okay, so those are easier, which is great. But now we have this third triangle that unfortunately we couldn't get any nice horizontal lines or vertical lines, so we do have to use the distance formula a couple of times maybe. But do I have a right triangle? Does it look like I have a right triangle? Almost. Which angle looks like it might be a right angle? Angle T, right? Angle T kind of looks like it might be a right triangle, a right angle, but how can we check just to make sure? How can I check if that's a right angle?
We can check to see if the sides are perpendicular.
Good, we want to see if those sides are perpendicular. So I need the slope for PT, not the distance now, we're doing the slope. So rise over run, use your eyes. What's rise over run? For PT. We're just doing slope of that side length, Jalen. So from P to T is a line. So we're finding the slope of that line. -3, good. The slope is -3. What about the slope of QT? One-third, 1/3. Are they perpendicular? Why not? Yes or no? Yes, yes. Okay. Yes, they are perpendicular. One of them is positive 1/3. The other one is -3. So yes, these are perpendicular. So I do have a right angle. So I can treat this like a right triangle, which is awesome. But now that I know it's a right triangle, I still need to know the height and I need to know the base. But since those are not straight horizontal or vertical lines, I have to use my distance formula. So I need to find the distance of PT and the distance of QT using the distance formula. So go ahead and try that on your own. Use that distance formula, figure out the lengths, and then we can finish this problem.
Miss, for PT, I got the square root of 10.
The square root of 10.
I was confused on what we were doing, but then I just did what I said on the screen.
Okay, let's check it. Why are we confused, first of all?
No. It's because when it took me out, you were talking.
Okay. Gotcha. Yes, so PT, so we have, let's see if you're right. -4 minus -3. What is that? -4 minus -3. -1. And then 4 minus 1 is 3. So 1 squared is 1, 3 squared is 9. So yes, we have the square root of 10. What about QT? Jalen has numbers. Are they the right numbers? Square root of 8. Okay, let's find out. For QT, I'm doing 3 minus -3. What is 3 minus -3? Careful. 3 minus -3? No. Let me write it out. There you go. 6. 3 minus -3, and then we're doing 3 minus 1. So yes, this would be 6 squared plus 2 squared. 36 plus 4 is 40. Square root of 40. So it looks like
I have to tell you something.
I have the square root of 10 times the square root of 40. Okay. Now remember, when you have radicals and you have two separate radicals that you're multiplying, you can bring them all under the same radical. So I can make this the square root of 10 times 40. What's 10 times 40?
400.
400. What's the square root of 400? 20. Good. 1/2 times 20. Final answer is 10. Well, that's not the final answer because now I have to add everything up and get my final area of PQRST. So 10 plus 6 plus 6, 22. There we go. So 2 of these were easy triangles, but that last one we did have to use the distance formula in order to get our area. How we feel? Do we have any questions?
No.
No? Okay. Let's see, we have 10 minutes. I'm gonna do a couple of, not challenge questions, but definitely just I wanna go over these. Okay, this came up on a test a couple years ago. You never know, sometimes they come back. So let's go ahead and take a look and I have a volunteer to read really quick. We only have 10 minutes.
I'll read.
Go ahead.
Oh my god, I'm so extra. Okay. Did you hear what Janelle said, Miss?
I did not.
She said extra for sure. Oh, that sounds bad. Okay, now. Sorry, miss, we were having technical difficulties.
That's okay. Go ahead. Go ahead.
Okay, this is why I wasn't talking. A homeowner wishes to put a fence around the space in her yard to create a dog pen. The space that she wants to fence is shown below, where each unit on the graph represents 1 foot. How many feet of fencing will the homeowner need to build the dog pen?
Okay. So she's using fencing to build this dog pen. Am I looking for area or perimeter? If we're calculating the amount of fencing that she needs, is that asking me for the area or is that asking me for the perimeter? Okay, Janelle's and Jalen, you guys are both correct. This is perimeter. She's building a fence. A fence goes around. Fence goes around. So I'm calculating all the way around. That's perimeter. Okay, so I need to know the perimeter, which means I need to calculate all the lengths. So let's go ahead. 3 of those will be easy. 1 of them will need the distance formula. So start with the easy ones. If I just call this A, B, C, D, give me one of these that I can write down. Let's go. Count those up. What can I write down? AB is 11. What else? AD was 14. Good. Keep going. DC is 13. Good. Now that last one, can't count it up. I need to use my distance formula. So let's do that really quick and then we'll be done. C is 6 comma negative 7. B is 4 comma 7. So the distance of BC is the square root of 4 minus negative 6 squared plus 7 minus, wait, hold on. Just 4 minus 6, my bad. 4 minus 6 squared plus 7 minus negative 7 squared. 4 minus 6 is what?
It's 148, man.
Ooh, okay.
6 is negative 2.
Mm-hmm.
Ooh, that bad quality. I'm gonna
That's
stop
okay.
talking.
That's okay. That's okay. And then yes, 7 minus negative 7. That's 7 plus 7, which is 14 squared. What's 14 squared? Yeah, it's not 148. What's 14 to the power of 2? That's okay. What's 14 times 14? Let's go. $196, and then 196 plus 4 is 200. So this is 200. This is the square root of 200. Now, can you take the square root of 200 and get a nice number? If you try it on your calculator, can you take the square root of 200? Or do you get something, an irrational number? Right, it's like 14.14 blah, 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 blah. It's an irrational number. So I'm going to leave it as the square root of 200 because look at the answer choices. These answer choices looks like they're going to keep it as a radical. So let's add up everything except for the square root of 200. What's 11 plus 14? Okay, because the perimeter is going to be 11 plus 14 plus 13 plus the square root of 200. So what? Ooh, Perla, your microphone is going crazy.
That horrible quality though.
Okay, so we get 38 plus the square root of 200, and look what they did. They turned the square root of 200 into, I forget what that's called, but they took one of those numbers out. So let's figure out how to do that. What is the square root of 200 can also, let's split that up into some factors. Is there a factor of 200 that you can take the square root of? Good, Jalen. 100. 200 is 100 times 2. Correct? With me so far? Okay. Well, I can take the square root of 100. What's the square root of 100? Oops. Square root of 100 is 10. So this is the same thing as 38 plus 10 times the square root of 2. I ran out of room. Let me fix that. But that looks like it's going to be answer choice. Answer choice C. Questions on this problem. That last step was the hardest one. So just making sure that we understand how they got that answer, 10 square root of 2. Do I have any questions on that? No? No? Okay. All right. So that is all for today. However, there is homework. I put it up already. It is due on Friday. So you have 4 days to complete it. It is on area and perimeter of triangles and rectangles and squares, quadrilaterals. On Khan Academy, make sure you get that done by Friday at midnight. Any questions before I let you guys go? All right.